Hi everyone, my name is Arzu and I'm a junior here at Arizona State University. Today we'll be talking about water pollution, but specifically ocean oil spills. About 10 years ago, when I was just an 11-year-old girl in the 5th grade, the news was popping with concerns about the Deepwater Horizon oil spill. I didn't give much of a thought to it until one night I saw Bill Nye, yes, the Bill Nye the science guy, on the news, talking about his thoughts and hypotheses on how to best clean up the ocean. Today, we'll be taking some time to create our own ocean and oil spill, and then learning the best ways to clean it up. But before we get there, let's take a deeper look into what exactly was the Deepwater Horizon oil spill.
The Deepwater Horizon oil spill, also known as the Gulf of Mexico oil spill, occurred on April 20th, 2010. On the night of April 20th, a surge of natural gas blasted through a concrete core recently installed in order to seal the well for later use. The natural gas traveled up to the Deepwater Riggs riser to the platform, where it ignited and resulted in killing 11 workers and injuring 17. The volume of the oil escaping the well was thought to have peaked at more than 60,000 barrels per day. The cleanup process was not an easy one, and took multiple years to clean up the ocean and the beaches. The Coast Guard cleanup patrol ultimately drew to a close in Alabama, Florida, and Mississippi in the June of 2013, and in Louisiana in April of 2014. That's 4 years after the initial accident. This image shows about 88,000 barrels of oil leaked into the ocean. That's only a small fraction of the total spill. This is a big picture of the damage, but if we were to zoom in, we would see all the animals and plants that were harshly impacted by the spill. After we do our own oil spill activity, we'll take some time discussing the environmental impact of the oil spill on all the plants and animals. I began my oil spill experiment by collecting all of my equipment and going outside in my backyard. Remember, you want to ask your parents or any guardian if you're able to use all the supplies that you need. Also, to avoid making a mess inside, I recommend you go outside to do this experiment. I chose to create my ocean in a tin baking pan. I filled the pan halfway with water and added some blue food coloring. The food coloring helps distinguish between the oil and the water, but it isn't necessary if you don't have any at home. I also have a small container of vegetable oil and an empty container where I can take out my oil from the ocean. These are the 3 materials I'll be testing today. I'll be trying to clean my ocean with a spoon, some napkins, and of course with some soap. After gathering all my supplies, I poured vegetable oil into my ocean. My final oil spill looked something like this. I chose to test my spoon hypothesis first. I tried to scoop out as much oil as I could without taking up too much of the ocean water. As you can see, it was pretty difficult, but I did my best. This is what my ocean looked like after I scooped out the oil with the spoon. It doesn't look too bad, but I lost quite a bit of my water too. Here's the container that I poured in the oil that I was scooping out with the spoon. You can see the little bubbles of water throughout the whole container. I chose to test my napkin hypothesis next. I took the oil that I had taken out with the spoon and poured it right back into the ocean to minimize waste. Then, I picked up my napkin and tried to dip it in the ocean water and tried to take out all the oil that I could. As you can see, it's not really easy trying to take out oil with the napkins. The water was seeping into the napkin as well, so I was picking up more water than I was picking up oil, and it took a long time. This is what my ocean looked like after I soaked up some of the oil with the napkin. As you can see, it didn't do as good of a job as the spoon did, but it made it a little bit better, I guess. Before testing my final hypothesis, I added some more vegetable oil into my ocean. Finally, I decided to test my dish soap. I poured some of the dish soap in, and as you can see, the oil moved all the way to the side. It dispersed all around the edges. Then I chose to take my spoon from the first part of my experiment and mix the soap, the ocean, and the oil together. As I continued doing this, the oil started to disappear. This is what my ocean looked like right after I mixed in the soap, the oil, and the water. And this is what my ocean looked like after sitting there for a minute or two after putting in the soap. Obviously, the soap did the best job, followed by the spoon and then the napkins. But why did soap clear out the oil? Let's find out. Take a moment to think about the following question. What is the relationship between oil and soap? Why did the oil disperse and disappear when we added the soap? I hope you've had a moment to think about these questions. Oil and water don't mix, so they separate into two different layers as we saw in our experiment. Soap breaks the oil into smaller drops, which can mix with the water, and that's why it disappears. This works because soap is made up of molecules with two different ends. One end of the soap molecule loves water, so they're called hydrophilic. The other end of the soap hates water, so they are called hydrophobic. The hydrophobic end of the soap molecules attach to the oil, and the hydrophilic ends stick onto the water. This causes the two substances to mix together. You might be thinking to yourself, the ocean doesn't have vegetable oil spills, so what kind of oil does it have? Well, you'd be correct in thinking it's not vegetable oil, or olive oil, or coconut oil, or any kind of oil you'd find in your kitchen. It's actually petroleum. Petroleum is vital to our society because of its role as a high-energy fuel. There are many advantages of petroleum, such as producing large amounts of energy, being easily and abundantly available compared to other fossil fuels, and the byproducts of petroleum are used to create cosmetics and plastics. Take a minute to pause this video and think about the following questions. What is petroleum? What products are made of petroleum? How is petroleum collected, processed, and distributed for use? What is the biggest danger of the distribution of oil? What is an oil spill? What are some ways the environment is affected by an oil spill? What are the effects of both the spill and the cleanup process? And what can we as humans do to avoid these problems in the future? Oil spills aren't the only way humans impact the environment. Think of some other ways that we can affect Mother Nature. What are some ways through which you can help minimize your carbon footprint? I hope you had the time to pause this video and answer these questions. I'm going to focus specifically on what the impact of an oil spill truly is. Spilled oil coats everything, including bird feathers, grains of sand, tree roots, and more. For birds, the oil on their feathers can prevent them from flying and can disrupt their natural waterproofing and insulation, which regulates their temperature. Crustaceans covered in oil may have trouble breathing as their blowholes are covered or oil seeps into their lungs. Ingestion and absorption of oil sickens both plants and animals in the area. After a spill, some of the oil eventually sinks to the bottom of the ocean. This damages underwater ecosystems and contaminates the fish and smaller organisms that are essential links to our global food chain. I hope this video inspired you to look a little bit deeper into the different ways humans can impact our environment. And I hope you truly enjoyed your oil spill experiment. Comment below and let me know all the different hypotheses you tested out today and the ones you found to be the best for an oil spill cleanup. Thanks for joining me today, and remember to check out some of these other cool and awesome take-home experiments. Keep investigating, scientists!